Okay, let's dive into percent composition today. It's a pretty easy concept, borrowing some skills you learned from molar conversions earlier this semester. So really what you're going to do is you're going to take the masses of all the elements of a certain compound, and you're going to break it up and know what percentage each one is. So if you want to think about it this way, it's the fraction for a given element, a mass fraction really. So we're taking 1 mole of one element on top and we're dividing it by 1 mole of the whole compound, which sounds a little more complicated than it is. It makes sense when you think about it this way. So let's look at an example. That's the best way to learn most of the time. The example we have here is ethanol, which is an alcohol, actually the most famous alcohol, the one that was outlawed and now is legal for people over 21. So ethanol has this formula right here, C2H5, and then the OH is a hydroxyl group that kind of gives you that clue that it's an alcohol. So what we're going to do is we're just going to go through and we're going to say, well, carbon has 2, and we know that from the subscript. And then, of course, hydrogen, you have to add the 5 plus the 1 to get your 6 right here. And after that, we're going to go to oxygen, which there's only 1. And notice I'm saying 1 mole, meaning it's got that subscript right there showing that there's 1 molecule. I go to my periodic table, and I'm going to go ahead and I'm going to round to the 100th spot. That's usually a good standard to go through. So I go to my periodic table and I round all these here, and I'm simply taking 2 times, so how many there are 2 carbons multiplied by the atomic mass from the periodic table to get these numbers right here. And now I have a pretty good idea of how to do molar mass if I didn't already. And I add all those up. And again, you've done this before. Make sure you do your sig figs here. And so I did go with 3 sig figs right here to multiply to get 3 sig figs. But remember, when I add these things here, I'm going by how precise it is based off of decimals. So we do go out to the 100th spot on all 3 of the numbers that we use to add. So 46.08 works. So what? Well, now we're going to take those numbers, and so the number I got, 24.02, that piece of the pie divided by the whole pie, and then I multiply it by 100. And I'll do this for every single element. So let me just slow down for a second. Again, I'm taking what percentage of the mass is carbon, 24.02. Again, I did that by multiplying how many there were, 2 times 12.01 from the periodic table. I always multiply it by 100 because it is a percent, and I want it to represent per 100. And again, I'm using my sig figs here. And notice I have 4 sig figs here because there are 4 here. There are only 3 sig figs here, so I'm going to keep that at 3 sig figs, and so on. Now you'll notice if you add all these up, more than likely, I don't think this one equals 100, but that's okay because we're using rounding and we're looking for an estimate. So that's how we would, there's one example of what we would do. Let's do another example, carbone, which is a chemical that's found in like peppermint, wintergreen gum, among other spices and things. So we're going to compute the mass percent of each element in carbone, okay? So same as before here, I'm going to look at carbon, and I'm going to say, okay, with carbon here, I have 10 of those, and from the periodic table, I know my atomic mass is 12.01. Move the decimal over, get my product. Hydrogen, there's 14. Multiply that, 14.14, and then oxygen, there's only 1 of them, which makes it easy getting that factor there, product. And so when I add these all up, again, I'm keeping my my sig figs going. Now notice here that I use sig figs here on this one and went to 4 sig figs. And when I added those up, I rounded to the 10th spot. So you're going that route there and getting the 150.2. So now you have all these pieces right here, and these pieces of the pie need to be divided individually by this number right here, okay? I guess that was an attempt at a square. Anyway, next up then, I'm showing how you're doing that and getting those percentages of each one. And again, if you added them all up, you probably won't get 100, but that's okay. Again, we're using rounding rules. Go ahead and give the next one a try, the penicillin, which is a pretty famous, the first antibiotic ever discovered, kind of very important one of the most important discoveries ever, that and vaccines, which we're very hopeful for one soon. So go ahead and look at this one, take your periodic table out, and compute the mass percentage of each of those elements in penicillin. And again, use this right here as your formula. Okay, so do that, pause, and see how you did. So hopefully you got these answers right here. I'm breaking those down and finding a great scientific discovery in penicillin. Okay, so hopefully you're now ready to do some questions on your own, and we stayed under 7 minutes, which is always kind of my goal. So let me know if you have any questions, and we'll take a look at more applications of percent composition.